Friends, good morning. Today we will discuss about the significant digits. So first of all, you are aware about so many type of digits, maybe zero or maybe perfect or imperfect. But right now we are discussing about some of the significant digits. These are the digits which are containing some of the specific part. They are playing whenever we are finding it on our answers. Let's say we have discussed about the type of errors. As you are aware that errors may occur because of lack of attention or maybe natural or maybe because of the instrument, and finally we can conclude the answer. But whenever we are finding it out our answer but it is not proper, there are also one thing we have to also carry about and focus about, that is called as the significant digits. So first of all, significant digits are our answer digit or number which are bringing us to its own importance, and it is giving you a perfect answer. So every digit has their own significance, and the same is the course we are following. There are certain rules for that. So first of all, very primary rule for that is called as all non-zero digits are significant. Let's say I have a number that is called as a 1 2 3 4. I have randomly placed this number, and you can just see that what is that number of significant digits are present in this digit I have placed. That is called as a 4, because all digits, because all are non-zero, so it is called as a all digits are significant digits. Then we have a 234. It contains the three digit non-zero digits, that is why all numbers are significant. Then we have 23.45 67. Then you can just say that there are six digits are there and all are non-zero, so all digits are called as a non-significant digits, sorry, significant digits. Then we have a 2.56789, so you can say that there are six digits are there, so all are significant digits. So this is the very simple and primitive rule for calling as a significant digits. Now we want to just say that all zero occurring between the two non-zero digits are called as a significant digits. Let's say our zero is preserved between two non-zero digits, then it is called as a significant. We are not caring about decimal points. We are not worried about any type of decimal points, whether you have a decimal point and so many zeros are there, or whether you don't have any decimal points. And again, we are not going to bother about. What we are just focusing is that there might be a number which is non-zero and our zero is preserved in between them, then it is automatically becoming that significant digit. So we have a 1007. So we can just say that our two zeros are preserved between that 1 and 7. So that is why both will become significant digits. So we have total the number of significance will be 4. Same as the course of our 0 is that we are not carried about the decimal points. And again another 0 is there. It is also like that. That is between that two non-zero digits. So our number of significant digits are 6. You are right now a little bit aware about that 2.009. So you can just see that our two zeros are there, again decimal points are there, but we are not carried about or driven by the decimal points, and we are living such type of decimal points whenever we are seeing such type of significant digits, and it is preserved between two non-zero digits. That is why we can just say that there are four significant digits we have. Now we have two, and then we have seven zeros. I have just told you that don't carry it by any number of zeros. That might be n number, but we have total seven zeros are preserved between two non-zero digits are called as a 2 and 6. So it will totally making that the significant digit is called as a 10. Then we have third number. It is called as our number, which is suggesting us that we have which is less than 0 or a right of a decimal. Let's say 0 is there, our number will be there, but the previous zeros are not considered as a significant digit, because the previous zeros are a part of a non-significant digit. But if you have a point fraction and the later zeros or and zeros are considered as a part of our significant digit, so you can just see that we have 0.000. So these all three zeros previously are not part of our significance journey, but the 0 which is over there, it is called as a 5704. It is preserved between two non-zero digits. That is why we can just say that it is having significance. That is why our significant digit is called as a 4. Now we have 0.02340. So you can see that on the screen that I have two zeros at a previously. It is not part of our significance journey. That is why it is not considered as a significant digit. But the later at the end we have zero, which is considered as a significant digit. So we can have that the total number of significant digits are called as a 4. So next one is called as a, you have later zero or your number will be higher one. It is not, you can just say that without decimal point, and it contains zero at the last point or at the end point. It is not considered as our significant digit. Let's say we have a 3210, so we cannot just consider this zero, so we can only consider this 3 2 and 1. So only our significant digits are 3. 34,000 we have. We are again not considering that last three zeros. So we are only considering this previously 34. So our significant digits are only 2. Next would be we have 34.000, but you are aware that decimal point is there. That is why we will consider all those zeros. So last digit is considered whenever decimal point is there. So we have a total 5 point, and there are called as a 5 significant digits. Same is the course for 0.006900. So you are aware that previous zeros are not part of our significant journey, but later late zeros are considered. So we can just consider this thing. So our total significant digits are 4. Now we have a 3.500. You are right now smarter enough to find it out whether it is significant or not. So we have total 4 zeros. Total 4 digits are there. So our significant digits are 4. Next is a course that is called 0.3570, same journey. You can just say that same points, last point is considered. So total digits are called as a 4 digits are there. Now changing that unit, we have next part. We have a 4.700 meters, and you can just say that 4.700. So you can consider that right now what we have is 4.700 meters. By changing units, you are not supposed to compromise with your significant digit. You can see that you have 4.700 meters. Either I am just putting that in millimeter, or maybe it will be in terms of kilometer. But our total journey will say that the last two digits are 000, and but decimal points are there. So we can just say that it is a part of our journey. That is why our significant digits are called as a 4. Same course I have mentioned that 4200 kilogram, but whenever you are just considering that 4200 kilogram, rather than put that 4.200 kilograms and multiply by 10 to the power 3. Here I haven't mentioned 10 to the power 3, but if you are just putting 10 to the power 3, it will make your journey better. Then and then you can just say that it is having significant digit 4. Right now I have placed in front of you some of the exercise. Let's say very first one is called as 0.003. You are aware that right now previous zeros are not part of our significant journey. Only 3 would be there. So only 3 will consider as a significant digit. So our answer of the first one is called as only one significant digit. In a second one, we have a 0.1570. It might be of any unit. We are not bothering about our unit. But previous zeros are not part of our significant journey, but last zeros are as per our rules. So we have total 4 significant digits. So our answer would be 4. Next one is called as the 2.64 cross 10 to the power 24. Mind well, whatever power it might be having positive or negative power, we are not at all in position to just include it. It is not our area of concern. So we have a 2.64. So we have only total 3 digits are which are called as the significant digits. The fourth one we have a 7.590. So after a point we have a 3 digits, and again after that there is 0. If there would not be a point, then we can just say that there are only 3 significant digits. But we have here decimal point would be there. So our significant digits are called as a 4. Next one is that we have a 6.032. We have a point fraction whether it is there or not, but our 0 is preserved between two non-zero digits. So our answer would be 4 significant digits would be there. Next one is called as a 3.012. Here you can just say that our power would be 10 to the power minus 4, but we are not in journey to just include this thing. So 0 is preserved between two non-zero digits, whether we have a significant digit or maybe decimal pointer there or not. So we have a total 4 significant digits. So these are the examples I have placed for you. Next is called as one illustration which is there in your textbook. You can find it out that state the number of significant digits and show that how many significant digits are there. So first of all you can have first of all A. that is called as a 0.007. So you can just say that previous zeros are not part of significant journey. So our only answer will be only one significant digit. Then we have a B. Power would be 10 to the power 24 is like that. That is the same thing we have just considered, that is having significant digit 3. The next one is called as the previous zeros are not considered and last zeros are considered. So we have a answer of a C would be only 4 significant digits. Next one will be 6.320 joule. It might be of any unit. We are not in a condition to bother about 6.320, so only 4 significant digits are there. Then we have 6.03. To our 0 is there. Decimal point is also there, but 0 is preserved between two non-zero numbers is the primary rule we have. So decimal point is not our area of concern. So we have a 4 digital significant digits we have. And next one is called as a 0 point. Previous 4 zeros are there, but it is not our area of concern. So this 0 is our area of concern, which is preserved between two non-zero digits. So this is the answer of your practice of a 2.10. Next, I have just mentioned already. Now we are in a position to just discuss about rounding off rule. Whenever you are dealing with the rounding off a rule, you are aware about our journey, which is called as a, either we are going to purchase anything or we are going to petrol pump and we are short of some single pennies. At that time, what we are doing is we are just dropping it some paisa, and that is the primary rounding off journey we had. But there are certain rules in physics we are following. First of all, if the digit is lesser than, last digit is a lesser than 5, then we are directly just dropping it off. So our answer, let's say we have, first of all, let's say 7.82 equals 2. So last digit is lesser than 5. That 2 is lesser than 5. So our directly dropping off is come to the 7.8. Same is the course for 3.94. Our the last digit we want to drop it off. It is lesser than 5, so we are just directly neglecting it, and then we have round off. It would be 3.9. So this is the primary number we had. Next rule is called as a, if we want to drop that number and that drop number would be higher than 5, then we are adding 1 to the previous part. Let's say in your screen my cursor is showing that our 7, which is more than 5. So we are just adding one more plus 1 to the previous part and just leaving that residual part. So we have a 6.87, that 7 is more than 5. So we are just dropping it off, and then we have a 6.9. Next is called as a 12.78, and you are aware that 12.78, that 8 is more than 5. So we are obviously adding one more to it, and that is why our journey will reach to 12.8. Next is called as a, if our digit which we are supposed to drop it out, and that the digit we want to drop it. Previously we have only after that point 2 points. Now after that point we have a 3 digits. So first of all, what we are just following is that 16.351 we have, and now we want to drop this up to point 3, and then we want to just remove that later part. So what we are doing is that if it has been like a digit other than 0, then the present digit is raised by 1 if our 5 is there. But after that 5, what is that? It is below, it is below than 5, or maybe after, then there is another rule that is called as a 0. But if we want to drop a 3, and then after 5 is there, and then after 5 there is a digit which is smaller than that, then what we are doing is that previous digit is either even or odd. So that is the only single digit you can just say that it is even or odd. After 5, what is there? After 5 we have uh, 1 or maybe 0 or maybe any number, but 5 is there, it is even number or odd number, that is called as an odd number. So we are adding 1 to it. Same is the course for 6.758. You can just see that after 5, that is 8, it is more than 5. So again, after 5 is there, yes, we want to drop it, yes, then we are just adding 1 more to it. So these are the rules. Same as the course, we have a rule that is called as either even or odd. So you can just see that it has been shifted data. So what I am doing is that shifting this data for you and placing this one for you. So my data would be, let's say, like this. So this is the thing which we have already discussed. Let's say my number which is called as either 0 and non-zero. So it is called as after 5 there would be a even number or odd number. So this is the journey of even on odd. If the digit to be dropped off is either 5 or followed by the zeros, then the present digit is raised by 1. Yes, the journey which I have to do is that after 5 there is a 0. So we are just automatically add one more to it. So my rule will be 3.750, 3.8. Same as the code 16.150, the 11 digit is a 0. So we are just adding one more to it. That would be 16.2. So this is the normal rules and regulation which we are just generally following. I have just made a practice for you that is called as 876 plus 0.4382. So it will give me the answer 876.4382. But I want to just reduce this up to only 3 digits. There are certain rules that we have to only follow up to the minimal number. Let's say you can just say that 876 means 3 digits are there, and 0.4382, it means that if we are just dropping that previous 0, we have a 4 digits are there. So we can only just reduce it to only 3 digits because we are following that minimal number theory. Whichever minimal number contains, up to that point we will just go to the round it off. In 876 we have minimal numbers are 3, so we are just following only minimal number of 876. Let's say we have 8.0 minus 0.42, we have a minimal numbers are 2, so we are just following this theory. 8.0 minus 0.42, it will give me 7.58. After 5 I want to drop it out, and whether it is a more than 5, so we are adding one more to the previous part. Let's say 4.6, there is a symbol I have to just place, that is called as a symbol. I am just putting it for you, and that is called as a multiplication symbol. So I'm just saying that 4.6 multiplied by 0.128, it will give me that 0.58888. But again I want to just drop up to this one. I have only 2 digits, so I have to just round it off only for the up to 2 digits. So what I am doing is that the last 4 is there. So first of all, if I am just removing this last 8, then my number will become 0.5, 8 and 9. I have dropped the last 8 from here. This last 8 is dropped. So it is more than 5. So it may raise one more answer to the previous part. The 1 is added. So it will give me 0.589. Again, I want to just remove this 589. So what I am doing is that I am just raising my number, so 0.59. So my last 9 is now removed, and it is more than 5, so plus 1 is added, so that is why my answer is 0.59. So such is the rule for the rounding it off. I have just placed some practice for you. This is actually the example. Let's say each side of our cube is measured by the 7.203 meters. So what are the total surface area of the volume of the cube? As you are aware that the volume of the cube is called as a 6L square. So my length or side length is given, that is called as a 7.203. So I can just say that 6 times L square is my basically area. So you can get the answer 1.299 and 254. But you can just see in the data it has been mentioned to us, that is called as our 7.203. Up to 4 digit we can just round it off. So 311 is a 3 digit and a 2 is already there. So we want to just drop it out the previous part. So I can just have a 9 at the end, which is more than 5. So plus 1 is added. So my surface area of the cuboid given to me is called as a 311.3 meters square. Let's say I have a volume of the cube. Again, you can say that the volume of the cube is called as L cube. You have a 4 digits, so we are just rounding it out up to 4 digit, 373.71. But our last one is a less than 5, so we are just directly without any hesitation drop it out because of our rule number 1. I have just placed another example for you, that is called as our diameter of the sphere is a 4.24. So I'm just dividing it by 2. It may give me that 2.12 centimeter, and I want to find it out that the surface area of the sphere. So you are aware about it. So surface area of the sphere is a 4 pi r square. So 4 pi r square is the area. So you can say that I have a 4.24, only 3 digits are there, so I have to just round it out up to 4, up to sorry 3 digits. I have 56.478. So after 4 I have 7, which is more than 5, so I have to add 1 to the 4. So that is why my answer would be 56.5 centimeters square. Now there is a practice for you. That is actually an example of your textbook, and that is called as the length, breadth, and the thickness of a rectangular sheet of a metal made up of having a length of 4.234 meters, then 1.005 meters, and I have 2.01 centimeter. Whenever you are converting such type of example, be careful. In the previous examples there is no such type of a change in the units, but here you have your units are changed. One is meter, another is also meter, and this one is in the terms of a centimeter. So that is why you have a 2.0101 centimeter. I have to just first of all just divide this one by 100 and convert in the terms of a meter, or either these two quantities I have to convert in the terms of a centimeter. I can say that 423.4 centimeter and 1.005 centimeter, or I can just simply say that this centimeter can be converted in the terms of a meter to 0.00201 201 meters. So either convert in the terms of a centimeter or meter. That is how you can just now your all components of length, breadth, and thickness are in terms of a same unit. After conversion of it, you are aware about that our formula of our area, which is called as the area of our rectangular shaped coil. So first of all, I am just putting that formula for you. The area would be, what we have is that twice times of LB plus BH and plus HL. So this is how you can just calculate your area. Now I want to find it out my volume. So you are aware that your volume is called as your cuboid of your LBN. Sorry, it would be LBH only, because I was having that fashion of a cuboid. So it is, you have rectangular shape, so your volume would be LBH. So after just multiply all those data, and you are capable enough to just convert in the terms of LBH. Next thing, that whenever you are just counting it as an answer, be careful that the lowest low significant digit you have to follow. And here you can just say that 2.01 contains only 3 points. That is why you can just find it out your answer only up to 3 digits. And these are the rules. So after this clip, you are familiar about how to calculate your significant digit and a round off. Hope you will follow all those rules and regulations till your studies of a physics or mechanics. So it would be quite easy for you to just calculate. So in the next time, we will discuss about different type of errors which we have already learned, but there are some of the formulas for it. Thank you.